An electric prototype designed in the midst of World War II could have prevented decades of urban pollution, but it was buried along with the rubble of a fallen regime. Before we begin, let me know in the comments where you are watching this video from, so I can gauge how far it has reached. Bavaria, 1942. The streets of Munich woke up under a blanket of fog mixed with factory smoke. In one of those industrial buildings, discreet and away from the massive armament plants, a small group of engineers watched with satisfaction as a vehicle moved silently through the inner courtyard. It did not emit the characteristic roar of gasoline engines. It emitted no exhaust gases. Only a slight hum accompanied its movement, so soft that one could hear the crunching of gravel under the wheels. That prototype was not a weapon. It was not designed to conquer territories or transport soldiers to the front. It was something much simpler and, paradoxically, much more revolutionary. An electric vehicle meant to solve a problem that had been tormenting Germany since the outbreak of the war: the fuel shortage. To understand why this project emerged at that specific moment, one must comprehend the situation the country was in. Germany had never been rich in oil. Even before the conflict, it depended on imports and costly processes to obtain synthetic fuel from coal. When the war expanded on multiple fronts, every liter of gasoline became a strategic resource of incalculable value. Tanks, planes, military transport trucks consumed astronomical amounts of fuel. Every drop allocated to civilian transport was one less drop for the war machinery. But life in the cities could not stop. Factories needed to move materials. Hospitals required supply transport. Basic urban services had to function. And all this without touching the fuel reserved for the war effort. The paradox was clear. They needed mobility without being able to afford gasoline. It was then that some engineers began to look towards a technology that, although old, had been forgotten for decades: electric propulsion. It was not a new idea. At the end of the 19th century and the beginning of the 20th, electric vehicles had competed on equal footing with gasoline ones. In cities like New York or London, electric taxis ran routinely. But the arrival of the Ford Model T, with its mass production and affordable price, along with the discovery of large oil fields, had sentenced the electric vehicle industry to death. By 1942, most people did not even remember they had ever existed. The German technical teams that resumed this technology were not visionary dreamers. They were pragmatists facing an urgent need. They worked in commercial vehicle companies that before the war produced delivery vans, urban buses, and utility vehicles. Now, partially reconverted to military production, they sought solutions for internal logistical problems. The first challenge was technical. The batteries of the time were not the compact and efficient lithium cells we know today. They were heavy, bulky, and had limited capacity. Lead-acid batteries, the most common, could store enough energy for short trips but added significant weight to the vehicle. The engineers had to design specific chassis, distributing the weight of the batteries so as not to compromise stability or load capacity. They opted for small, light vehicles with simplified bodies. No luxuries or superfluous finishes. Every kilogram saved in the structure meant more autonomy or more transport capacity. The initial prototypes barely exceeded 2 meters in length. They could carry 2 people or an equivalent load. Their top speed was around 40 kilometers per hour, enough for urban travel. But there was something in which these electric vehicles greatly surpassed their gasoline equivalents: maintenance. An electric motor has far fewer moving parts than a combustion engine. There are no pistons, no valves, no complex exhaust systems. Fewer parts mean fewer breakdowns. In a war context, where spare parts were scarce and every workshop hour was crucial, this mechanical simplicity was a huge advantage. The first vehicles were tested in controlled environments: armament factories, military bases, airfields, places where routes were predictable and distances short. An electric vehicle that could travel 30 kilometers on one charge was more than enough for moving within an industrial complex or making deliveries within a limited urban radius. The results were surprisingly good. Drivers reported handling easier than conventional vehicles. The electric motor offered maximum torque from the start, facilitating starts and maneuvers in tight spaces. The silent operation was especially valued in environments where verbal communication was important or where noise could be a safety issue. One of the most fascinating aspects of these prototypes was their charging system. Public charging stations did not exist, of course. But Germany had a relatively developed industrial electrical infrastructure. Factories, military workshops, all had electric supply. Implementing charging points required no large investments. It was enough to install suitable outlets and basic control systems. The engineers even developed interchangeable batteries for some models. Instead of waiting hours to recharge a battery, the entire module could be swapped in minutes. This solution, today touted as innovative in some electric mobility projects, was already being explored more than 80 years ago. But these vehicles were not just a technical solution. They represented a different vision of urban mobility. Although born out of military necessity, their design and capabilities made them perfect for civilian use in cities. They were compact, ideal for narrow streets. They did not pollute, which back then was not an environmental concern but a public health issue in industrialized cities. And they were economical to operate, considering electricity was cheaper and more accessible than fuel. Some documents from the time suggest there were plans to expand production beyond the military sphere. Urban transport companies, postal services, local couriers, all could benefit from these vehicles. In a post-war scenario, when fuel scarcity was expected to persist for years, electric vehicles seemed a logical bet. But history, as we know, took another path. The German defeat in 1945 not only meant the end of the Nazi regime, it also meant the systematic dismantling of its industrial capacity. Factories were occupied, many dismantled, others converted under Allied supervision. Research and development projects, especially those with military connotations, were archived, confiscated, or simply abandoned. Electric vehicle prototypes fell into this category. Although their application was clearly civilian, they had been developed in the context of the German war effort. Everything carrying that mark was doomed to oblivion. There was no space to rescue ideas from the defeated enemy, no matter how useful they were. But there was another factor, perhaps more decisive. Cheap oil. The post-war period brought a radical change in the global energy market. Middle Eastern oil fields began to be exploited massively. The United States, with its production at full throttle, flooded markets. Fuel prices dropped dramatically. What during the war had been a scarce and precious resource became abundant and cheap. In this new context, who would invest in electric vehicles? Gasoline was cheap, distribution infrastructure already existed, and combustion engines were known and mastered technology. Electric vehicles, with their heavy batteries and limited autonomy, seemed an uncomfortable relic of times of scarcity. Europe, devastated by war, needed to rebuild quickly. There was no time or resources to experiment with alternative technologies. The priority was to get the economy running, and that meant using what worked, what was simple, what was available. Gasoline engines met all those requirements. Thus, the German electric prototypes vanished. Some ended up as scrap. Others were forgotten in warehouses that nobody reopened. Technical documents scattered, some lost, others archived in collections no one consulted. The engineers who worked on these projects rejoined the conventional industry or immigrated to other countries. By the 1950s, the electric vehicle was seen as a historical curiosity, something that perhaps worked once but had been surpassed by modernity. The future was the gasoline car, large, powerful, a symbol of progress and freedom. For decades, no one questioned this model. Cities were designed around the automobile. Infrastructures adapted to facilitate fossil fuel-based transport. The automotive industry became one of the pillars of the global economy, and everything revolved around increasingly larger and more powerful engines. But the problems the German electric prototype tried to solve never disappeared. They were only postponed. Urban pollution became a public health crisis. Vehicle emissions contributed to climate change. Oil dependence generated geopolitical conflicts. Cities became saturated with traffic and noise. All things those small, silent 1942 vehicles did not cause. It was not until the 1990s, and especially the 21st century, that the world began to rediscover the virtues of electric mobility. Companies like Tesla demonstrated electric vehicles could be desirable, powerful, and commercially viable. Advances in battery technology, especially lithium-ion, resolved many limitations of old prototypes. Today, governments worldwide promote the transition to electric mobility. Networks of charging stations are being built. Incentives to buy electric vehicles are offered. Deadlines are set to stop selling combustion engine cars. All this, presented as 21st century innovation, had already been explored 80 years earlier in Bavarian workshops. The irony is evident. If those prototypes had been developed in a different context, if they had not carried the mark of a criminal regime, if oil had not become so cheap after the war, perhaps the history of urban mobility would have been different. Perhaps cities would have grown differently. Perhaps we would have avoided decades of air pollution. But history does not work with conditionals. What we can do is recognize that solutions to our current problems are not always new. Sometimes, they are forgotten ideas waiting to be rediscovered. The electric vehicle is not an invention of the 21st century. It is a century-old technology abandoned for economic convenience and historical circumstances. The German engineers of 1942 faced a concrete problem: mobility without fuel. They developed a functional, practical, and scalable solution. That this solution was born in the worst possible moment, in the context of a devastating war, does not invalidate its technical validity. Today, when we talk about energy transition and sustainable mobility, it would be worth looking back, not to glorify the past, but to understand that many of the questions we ask have already been answered before. The answers were archived, not because they were wrong, but because the world chose another path. The German electric prototype demonstrates something fundamental about technological progress. It is not linear. We do not always move forward. Sometimes we go backward, forget, abandon paths that could have been better, and decades later, we retrace our steps, convinced we are innovating, when in reality we are recovering what was lost. Those small silent vehicles that moved through German military bases and factories were not perfect. They had obvious limitations. But they solved real problems with available technology. They were proof that urban mobility without fossil fuels was possible, even with mid-20th century technology. They did not need the latest generation lithium batteries. They did not need sophisticated electronic management systems. With lead-acid batteries, simple electric motors, and pragmatic designs, they already offered a viable alternative for certain uses. If that alternative had developed in times of peace, if investment had been made to improve the technology, if it had not been buried with the ruins of the war, where would we be now? It is impossible to know. But we can imagine cleaner, quieter cities, with an electric mobility infrastructure developed over decades. We can imagine an automotive industry that never abandoned electricity, that perfected batteries and motors over generations. Instead, we chose the path of oil. Not because it was the best, but because it was the easiest, the most profitable in the short term, the one that required fewer changes. And now, 80 years later, we are trying to undo that path. We are investing trillions in developing what already existed, in building infrastructures that could have grown organically for decades. The German military electric vehicle prototype is an uncomfortable reminder. It shows us that the crises we face today are not inevitable. They are the result of decisions, priorities, economic and political choices made in the past. It also shows us that innovation does not always come from where we expect, that even in the darkest contexts, valuable ideas can emerge. And judging a technology by its origin rather than its merits can be costly. Today, those prototypes no longer exist. The few that survived are in museums, curious pieces of a history few know. But their legacy should be greater. They should be recognized not as a historical oddity, but as pioneers of a mobility model the world desperately needs. They were not forgotten because they failed. They were forgotten because the world was not ready to change, because it was easier to continue as always, because oil was too cheap and convenient to resist. But the things we forget have a way of coming back. And here we are, decades later, rediscovering what those engineers already knew. Urban mobility does not need gasoline. Electric vehicles are practical, efficient, and viable. The future of transport lies in abandoning fossil fuels. It just took us 80 years to return to the same point. 80 years of pollution, oil dependence, and climate crisis. All because we chose to forget a lesson we had already learned. The German electric prototype did not transform urban transport when it could have. But its story teaches us something equally valuable. The best solutions are not always new, and forgetting the past can condemn us to repeat avoidable mistakes.